Looking at an exponential function in a word problem, we have a cancer patient's white blood cell count grew exponentially after she completed chemotherapy treatment, which is very typical when you get chemo. It does kill the cancer, but it also kills off your immune system. So your white blood cell count drops, and typically it's too low to even leave the hospital. A lot of chemo is done inpatient for this reason. They wait till the blood counts are high enough to let them go out and have some sort of an immune system. So initially, she starts with a 54 white blood cell count, something super low, but we know it has a growth rate of 14% per day. We want to let C represent the white blood cell count per milliliter and D represent days after the treatment is complete. We're going to use that to write our own exponential function. So we have our 3 steps to writing y equals C times A to the x. So first step, we need the initial amount. Well, here, that 54 is the initial amount of white blood cells. Our second step is to find A. So we want to figure out what A is. Normally we would plug in the other point if we're given one, but here we're given the growth rate was 14%. So we want to figure out what that is as a growth factor. So I'm going to take that 14% and make it so that it's not a percent anymore. So let's divide it by 100 to make it a decimal of 0.14. But we want to have growth, so our answer has to be bigger than 1. So I'm going to add 1 to this. That way we get 100% of the cells plus then some. So if we take 54 and multiply it by 1, we'll stay at 54. But if we take 54 and multiply it by 1, 0.14, we're going to get 14% bigger each time. So my growth factor is 1.14. There's my A. We're given the rate. We're change it to be a factor. So our last step is to write this function. Instead of calling it y, it says call it C of D equals our 54, the initial amount, times our growth factor is 1.14, which stands for a 14% growth rate. And we're going to raise it to D, the number of days since treatment. That is how her white blood cells are recovering. The next part says, if growth continues, what would her white blood cell count be after 30 days? So I've done this before with my sister. When she had chemo, we had to stay in the hospital for 30 days. Every day they checked her white blood cell count, and every day that it was more was a day closer to going home. So a typical time that they gave us, they said, hey, it's probably going to be 30 days, but we will check every day, and if we can allow you to go home, we will. So let's check what her count is going to be after 30 days. So we're going to plug in 30 for D and just grab our calculator, do 54 times 1.14 and raise it to the 30 power using the caret button on the calculator above the divide symbol. And her white blood cell count started at 54 but is growing by 14%, or a factor of 1.14. And to round to 2 decimal places, the 100th place, she has a white blood cell count of 2,751.31, and this is white blood cells. So according to the model, that's what her count should be, and they can decide, is that a safe enough count to maybe at least go outside and ideally go home. The last part says, algebraically determine how many days it will take for her white blood cells to double from her original amount. So how many white blood cells are they looking for her to have? If they're looking for how long it takes to double, well, initially she had 54. So we're going to figure out what is double of that going to be. 54 times 2, that would be 108 white blood cells. And this might be a factor to estimate recovery and how her treatment went and all that good stuff. How long is it taking for her immune system to double the white blood cells? So there's probably a typical amount of time, and they want to make sure each patient is getting healthier and stronger and having it double in a certain amount of time. So we want to figure out, in this formula, we're going to set our count to be 108 and solve for how many days that takes. So we're going to write 108 equals 54 times 1.14, our equation from above, to the d. And I'm going to get d by itself. Well, it's the top, it's at the exponent, so we're going to have to use logs to solve this exponential. So first of all, I want to get it on one side by itself, so I don't want it to be multiplied by 54 anymore. And so 108 divided by 54, no surprise there, that's 2, because we're doubling it. I'm going to leave some space here. I have 1.14 raised to the d power. And to solve for an exponential, we need to take log of both sides. So I'm going to do log of 1.14 of 2. And on this side, log of 1.4 raised to the d will bring down that d power. And I can enter it in just like that. If you can hit math and scroll down on your calculator, that's what I would do now. If you don't have math and the change of base option, that log base option, you can use your change of base formula. We're going to do ln of 2 divided by ln of the base goes on bottom, ln of 1.14. Either option should give you the same answer. And we're going to round to the nearest day. So D is 5.29. So sometime during day 5, she'll have doubled her white blood cell count.